Hi everyone, welcome to Cognify. So in today's video, we're going to be looking at three questions. Okay, so we're going to be mostly tackling functions, understanding different ways of deriving solutions. So in the first question, we're going to be looking at finding the coordinates of the turning points of a parabola. So we are given a parabolic function, and what we need to do here is find coordinates where that parabola changes its direction, right? So as you know, a parabola could go with this function here, it will have a shape that looks like that. So now we want to find the turning point. So if we look at this parabola here, okay, the turning point would be somewhere here, okay? So we're going to be finding, there are actually two different ways we're going to implement here to find that solution. Next question, we're going to be looking at the hyperbola. So we are given a hyperbola and it's transformed. Okay, so it's shifted 4 units to the left and then 3 units up. And lastly, we're going to be finding the turning point of another parabola. Okay, so we're going to test out the two methods above and try and see if we can implement it here as well. But let's go ahead and start this. So in the first question, we are given the parabolic function defined as f of x is equal to x squared minus 4x minus 5. So now we want to find the turning point. So there are two ways of doing this. Okay, the first way is using differentiation. Okay, so when you're differentiating a function, okay, and you input a value at okay, at that particular point, you're going to be finding the gradient at that point. So if we go back to our graph here, right? So let's say it looks something like, okay, you've got this here. So now we know if our function goes from left to right, okay, so going down, down, we know here at this particular point here, the gradient will be quite high, okay, at that point here. And then as the function progresses, the gradient is going to drop, drop, drop. Then it's going to reach this point here at the turning point, where if we were to draw a horizontal line here, right, we can see visually that the gradient would have to be 0. Okay, so that's where the turning point is. So one way to find that solution is to differentiate and equate the output to 0, because at that point there the gradient is 0. So when we take f prime of x, okay, so we are differentiating it with respect to x. So now when we're differentiating this, we will mostly be working with these two, right? So terms here that have an x attached to it. The constant, when you differentiate it, you always get a 0. So the derivative of x squared is simply 2x. So when you differentiate, we take the exponent, bring it down, and then reduce its power by 1. That's what you do anytime you differentiate. Next one, we do the same thing, right? Derivative of 4x would be what? It's going to be 4. Okay, so the x disappeared, right? Why? Because when we differentiated that function, right, we brought the 1. It's good to expand on some of these concepts because you're going to be applying it in other scenarios. So when you differentiate, let's look at the x, right? The 4 is a constant, so it's just there. So when you differentiate the x, the 1 comes to the bottom, okay, times. Then we've got the x, right? That power is reduced by 1. So the output here is simply x to the 0, okay? And x to the 0 is simply 1. So x to the 0 is equal to 1. That's why we only have a 4 here. And lastly, derivative of 5. Okay, the 5 is a constant, so it's going to be 0. So now we've differentiated and we have 2x minus 4 as our output. The next step is to equate this to 0. Because if we go back to what we were discussing at the beginning, okay, at the turning point, okay, if we were to draw a horizontal line, right, that horizontal line will touch that point, okay? So from your understanding of gradients of functions, right, the horizontal line, that tells us that the gradient is 0, okay, because there is no change in the y value. Because you know the gradient is basically change in y over change in x, okay? So if we go from, if we look at our horizontal line here, right, if we were to find the gradient, okay, there's no change in y. That's why our gradient is 0 at that point. But that's basically it, okay? So now we equate this to 0 and then we solve for x. So 2x, I'm just going to transpose the 4 to the other side, and then x is equal to 2. So now we found that point, right? So you take that point and then substitute it into the original function, which is this one here. So now if we substitute 2, what do we get? 2 squared minus 4 times 2 minus 5. So now if we simplify this, what do we get? It's going to be 2 squared is 4. 4 minus 8 is minus 4 minus 5 is minus 9. So now if we look at our list of options here, firstly, let's just abide this as a coordinates. It's going to be first is x and then it's y. So our coordinate is 2 and minus 9. So if we check through our options here, the only possible one is B. So that is one way of doing it, okay? The other way, I'm just going to give you a formula and you will try it out yourself and check if it coincides with the solution we got here. So the other method you're going to use is, you're just going to use this formula, right? Once you get x, you will be able to find y, okay? So we just use this formula here, minus b over 2a. So b and a are constants, which you can derive from a parabolic function, which you should know, because you remember there's this formula here, right? Minus b plus minus square root of b squared minus 4ac divided by 2a. So use this formula to find solutions of x, okay, for functions that they cannot be factored the normal way, okay? So this should give you a hint, right? So you should be able to find your constants b and a. Once you get your solution, then substitute it into the function, this one, and then you get an output. Then just compare. So these are two different methods that you can use when trying to find the coordinates or turning points of a parabola. Next question. So in the next question, we are given a graph, right? Defined as y equals 1 over x, which is shifted 4 units to the left and 3 units up. That is the new equation. So before we find the solution, right, let's first draw the graph, okay? So that we can visualize it. So our function is, let's see here, our function is defined as 1 over x. So now let us plot something here, right? 1 over x, what does that tell us? Let's look at the asymptotes first, right? So asymptotes will serve as a barrier, okay, or a limit which our function approaches but never touches. So if we check here, if we look at our function, right, we can clearly tell that x cannot be equal to 0, okay? Because that would make our function undefined. So x is equal to 0 if we look at our coordinate axis here, right? So we'll see it will be at this point here, vertically. So our function will approach this vertical line, but will never touch it. So I'll just put a 0 there, okay? And let us see here, what would it look like? Okay, so a simple way to do this, right? We just need a few points. A few points in the negative x from the negative side, the x-axis, and a few points from the positive side. So we're going to be using, let's see, let's consider terms such as x is equal to, just need 2 from each side. So -2, -1, 1, and 2. So now if we check here, we'll have 1 and 2, -1 and -2. So now if we check, let us substitute, right? For x is equal to -2, okay? Then y is equal to -0.5. So now if we check here, my x minus 2, y is equal to -0.5. So it's going to be somewhere there. Next point, x is equal to -1, right? So y is equal to -1 as well. So at -1, y is also -1. So it's somewhere there. Okay, so let's label it. This is going to be -0.5 here. It's going to be -1. And then next one, it's going to be x is equal to 1. Y is equal to 1. Okay, x is equal to 1. Y is equal to 1. Next, x is equal to 2. Y is equal to a half. Okay, so it's going to be somewhere there. So now what do we see here? Okay, we've plotted 2 points from both sides, and we can see that from both sides, right, they are approaching x is equal to 0. Okay, so let us see here. So it's going to look something like this. So we'll have our function going down, touching 1, then touching 2. So would it cross the y-axis, meaning where y is equal to 0? Okay, so this boundary here. So if we look at our function, right, as the value of x rises, good to understand such concepts because this will help you to understand how these functions behave. So as x gets bigger and bigger, right? So let's say x is getting bigger and bigger. We can denote this by saying x tends to infinity. What would happen to our function? Our function will tend to 0. Okay? It will tend to 0, meaning it won't touch this plane here, our horizontal plane. It will just approach it. So our function is just going to keep going and going indefinitely. Same thing up there. Okay? And then on the left side here, where we chose negative points of x, what do we see here? Our function, if we were to consider x going negative from -1, -2, -3, all the way to higher negatives, right? What happens to our function? Our function will also tend to 0, meaning it approaches 0, okay, but never reaches it. So this is what it would look like. So I'm taking my time to go through these concepts because it will help you tackle any other type of question, right? Related to hyperbolic functions. So understand the concepts can help you break any type of question down like we are doing here. So now if we go to the question, right? So the function is shifted 4 units to the left and 3 units up. So this one, it will simply be, let's write it here. So our function is 1 over x, right? So our function is shifted 4 units to the left, okay? So what does that mean? Being shifted 4 units to the left. It means our asymptote, okay? asymptote here, which we've defined as x is not equal to 0, okay? And also another restriction here is that y cannot be equal to 0. So we've got two asymptotes, okay? So now, in this case here, we are shifting 4 units to the left. So we are shifting the vertical asymptote, right? So this asymptote here. So x is not equal to 0. So now this is going to change. So from x is not equal to 0, we're going to be changing it to what? That's what we want to find out. Okay. So now our function is being shifted 4 units to the left. Okay. So x cannot be equal to -4. Okay. Because our asymptote is being shifted. So if we were to, let us quickly just put a horizontal line. Okay, if we were to take -4 as somewhere here, let me just put it there. Let's put it there. Okay. So this point here, at this point here, right, it's -4. So what we did was that we shifted our asymptote 4 units to the left. Okay, so by shifting that 4 units to the left, our function then has a new asymptote. So in this question here, we are basically adjusting the asymptotes, okay, across both x and y. So if we were to transpose this, right, and integrate it into our function here, okay, while also considering this other portion here where our function shifts 3 units up, okay? So our function shifts 3 units up. What does that mean? Okay, that y is basically equal to 3. Okay, initially y was equal to 0. Okay, which is here. Okay, but now we are adding 3 units to our function. Okay, but that affects this value here, which is defined as q. Yeah. So this is a parameter used to define that constant in our function. So that constant helps to shift the function in the up or down. So if it's 3 units up, we add 3. If it's 3 units down, we minus 3. Okay. So now if we integrate both of these, what do we get here? So now, let's see. So our new function is equal to 1 divided by x plus 4. Okay. Because you remember from here, x cannot be -4. And then we add 3. And that is basically it. This is our new function. So you can, let me just put it here for you. So our new function, what would it look like? Okay, so we understand what the shape looks like. So all we have to do is just shift it. So it will look something like this. Okay. Let me, there's a euro. Jesus. Sure, babe. Listo. Chills. Let me see here. Let's include a horizontal line. Okay, so it's going to be y is equal to 3, right? Let's just simply use that. Okay, so at this point, we also need to include this portion here, this other asymptote, okay, where we added 3 units to our function. So now what this means here is that our function right now has 2 new asymptotes. So this one here and this green one. So now our function will look something like this. Okay, and in the other side, we'll expand this. It's going to look like this. It's a bit untidy, but hopefully you get the idea. Okay, we simply just shifted the asymptotes and then retool. So that is basically it. And in the next question, what is the turning point of a parabola defined by f of x is equal to that. Okay. So now for this question here, I'm going to leave it up to you to attempt it. I'm going to leave the solution in the description. And if you have any comments, please add them in the comment section. And please share other approaches if you have them. And yeah, till next time.